Okay, secondary educators, it's time for us to think about something that's a little bit bizarre. What do we mean when we talk about real exponents? What do we mean when we try to figure out what 3 to the square root of 3 power is, or what pi to the e is? What do those even mean? Because the meaning that we gave uh, exponents way at the beginning of exponents so doesn't apply here. What does it mean to multiply radical 3 copies of 3 together? Like, what does that even mean? And this is not a rational number, so it's not like we can use the P over Q rational exponent definition. What does that mean? How do we even try to deal with this? Well, every real number has a decimal approximation. And as we have studied, this is the limit of a Cauchy sequence of rational numbers. So if we have a limit of a Cauchy sequence of rational numbers, the sequence of rational numbers, the terms of the sequence of rational numbers get closer to each other as we go. So if the terms of the sequence get closer as we go, it would stand to reason, and we can prove, that exponentiating to those terms produces a sequence whose terms get closer to each other as we go. So pi to the e is the limit of the sequence pi to the 2, pi to the 2.7, pi to the 2.71, and so on. When we say pi to the e, it does not at all have a meaning that is connected at all to the definition of exponents that we told kids when they were 13. It's the number of copies, and you multiply all the copies together. This has gone so far away from that definition, but it's built on that definition because our understanding of pi squared comes from that definition, and our understanding of pi to the 2.7 even comes from that definition. We take the 10th root of pi, raise that to the 27th power, we get a number. We take the 100th root of pi, raise it to the 271st power, and we have a number. And those numbers get closer to each other as we go. So the sequence settles down, and when the sequence settles down, it's got a limit, and that allows us to talk about pi to the e. And what this does is it fills in all the holes that are created when we talk about the rationals. Because like you got a lot of numbers between pi to the 2.7 and pi to the 2.8, right? You've got a lot of numbers in between there. Most of them are irrational. Almost all of them are irrational. So this process fills in that gap, and it fills in all those gaps with no holes. That's what's so important to think about. And that's what lets us do this. Because we do this with kids, right? We graph pi to the x, and we just graph it like this, even though most of the numbers here whose outputs we are finding and graphing, most of those are irrational inputs. So I mean, very rare is the pi to the 0, pi to the 1, pi to the 2, right? Like those are really rare. And then there are some rationals in there, right? There are rationals in there, but not many. I mean, most of the numbers in blue are irrational. So we need a way to fill in the gaps with no holes, and the way we do that is with a Cauchy sequence. So there's some understanding of some things you've never thought about before, or perhaps have never thought about before, and I hope that this is helpful. My 5 minutes are up.